Breaking news, 3I/Atlas isn't acting like any.
What happens when our sun literally fires a plasma cannon at a mysterious visitor from another star system? Well, we just found out, and the results are absolutely mind-blowing. This week, something unprecedented happened in our solar system. Something that's never been witnessed before in human history. And it might change everything we thought we knew about interstellar visitors. Back in July of this year, astronomers discovered something extraordinary. Our third confirmed interstellar visitor. They named it 3I/Atlas, and from the moment they spotted it, this thing has been breaking all the rules. Picture this, a cosmic visitor screaming through our solar system at an absolutely insane 137,000 miles per hour. That's fast enough to travel from New York to Los Angeles in about 2 minutes. But speed isn't the only thing that makes 3I/Atlas special. It's massive. Remember Oumuamua, that cigar-shaped object that visited us back in 2017? It was about a quarter mile long. The second visitor, 2I/Borisov, was about 0.6 miles across. Well, 3I/Atlas absolutely dwarfs both of them. We're talking about an object that's at least 3.1 miles across and weighs more than 33 billion tons. To put that in perspective, that's like having 6,600 Empire State Buildings condensed into a single cosmic bullet racing through space. But here's where it gets really weird. This isn't just any random space rock. 3I/Atlas has a chemical composition that's completely off the charts. When scientists analyzed its makeup, they found it has a much higher ratio of carbon dioxide to water than anything we've seen before. That's like finding a car that runs on orange juice instead of gasoline. Technically possible, but definitely not what you'd expect. And then there's its trajectory. Harvard astrophysicist Avi Loeb, and yes, this is the same guy who suggested Oumuamua might be alien technology, has been studying 3I/Atlas's path through our solar system. What he found is frankly unsettling. This object's trajectory takes it suspiciously close to 3 major planets, Jupiter, Mars, and Venus. Next week, and I mean literally next week as I'm recording this, 3I/Atlas is going to pass within just 1.67 million miles of Mars. Now, 1.67 million miles might sound like a lot, but in cosmic terms, that's like threading a needle while blindfolded. Loeb called this remarkable fine-tuning, and honestly, that might be the understatement of the century. Now here's where our story takes a dramatic turn. Earlier this week, our sun decided to give 3I/Atlas a very unwelcome greeting. The sun unleashed what's called a coronal mass ejection, basically a massive blast of plasma and magnetic fields aimed directly at our interstellar visitor. Let me paint you a picture of what a coronal mass ejection actually is, because this is some seriously powerful stuff. Imagine if you could take all the energy from 1 billion hydrogen bombs and launch it into space as a wave of superheated plasma traveling at millions of miles per hour. That's essentially what hit 3I/Atlas this week. These coronal mass ejections are no joke. When they hit Earth, which thankfully doesn't happen very often, they can knock out power grids, disable satellites, and create auroras visible as far south as the Caribbean. Now imagine that same force hitting a mysterious object from another star system. This is the first time in human history that we've witnessed a coronal mass ejection colliding with an interstellar object. It's like watching 2 titans clash in the cosmic arena, and we had front row seats. The collision was captured by space weather monitoring systems, and according to spaceweather.com, it's an exceedingly rare event. We've seen similar collisions with comets from our own solar system before, like back in 2007 when NASA's Stereo, a spacecraft, watched a comet named Encke get blasted by solar material and temporarily lose its tail, but that comet reformed its tail within minutes because it was used to our sun's behavior. But 3I/Atlas? This visitor has spent potentially millions of years traveling through the cold void between stars, and now it's getting hammered by one of the most violent forces our solar system can produce. As 3I/Atlas has been approaching its closest point to the sun, what astronomers call perihelion, something absolutely fascinating has been happening. The object has been getting brighter, much brighter. And here's the kicker, it's glowing green. Now, when something in space starts glowing green, that tells us a very specific story. The green light is coming from diatomic carbon, basically pairs of carbon atoms that are getting energized by solar ultraviolet radiation. When these carbon molecules get hit by UV light, they emit that distinctive emerald glow. This green glow is like a cosmic signature, telling us that 3I/Atlas is actively outgassing as it gets closer to our sun. It's literally releasing material into space, creating what's essentially a tail like a comet. But remember, this isn't just any comet. This is a visitor from another star system that's potentially been traveling through space for millions of years. Think about that for a second. This object has survived the journey between star systems, enduring temperatures just a few degrees above absolute zero, cosmic radiation, and the vacuum of space. And now, as it encounters our sun for the first and probably only time, it's putting on this incredible light show. The fact that it's producing so much carbon-based material also adds another layer to the mystery. Most comets in our solar system are primarily made of water ice with some rocky material. But 3I/Atlas seems to have this unusually high carbon content, which could tell us something important about the star system it came from. Some scientists are wondering if this high carbon content could indicate that 3I/Atlas formed around a carbon-rich star, or in a region of space with different chemical compositions than our own solar neighborhood. It's like having a messenger from another world, carrying chemical signatures from a place we may never be able to visit. Now, you might be wondering, how do scientists actually figure all this stuff out? How do they know 3I/Atlas is glowing green, what it's made of, or how fast it's traveling? Well, buckle up, because the detective work happening right now is absolutely fascinating. When astronomers observe an object like 3I/Atlas, they're not just taking pictures. They're using something called spectroscopy, basically breaking down the light coming from the object into its component colors, like a prism splitting sunlight into a rainbow. But this isn't just pretty colors. Each element in the periodic table has a unique fingerprint in the spectrum. That green glow we talked about, that's just what our eyes would see if we could look at 3I/Atlas up close. But spectroscopy reveals so much more. Scientists can see absorption and emission lines that tell them exactly what molecules are being released as 3I/Atlas heats up. The carbon dioxide, the water vapor, even trace elements, they all leave their signatures in the light. But here's what's really blowing scientists' minds right now. As 3I/Atlas gets closer to the sun, its brightness has been increasing in ways that don't quite match standard comet models. Most comets brighten in a predictable pattern as they approach the sun. It's actually one of the ways we can calculate their size and composition. But 3I/Atlas has been showing unexpected fluctuations. Some researchers are calling this anomalous outgassing behavior. In plain English, it means 3I/Atlas is releasing material in bursts and patterns that don't match what we typically see. It's like watching someone breathe, but their rhythm keeps changing in ways you can't predict. This could mean several things. Maybe the surface of 3I/Atlas is more uneven than typical comets, with pockets of volatile materials that get exposed to sunlight at different times as it rotates. Or perhaps the composition is so different from our solar system's comets that it's behaving according to rules we haven't fully figured out yet. Then there's the rotation mystery. Scientists have been trying to measure how fast 3I/Atlas is spinning, and the data is complicated. Different observation teams are getting slightly different results, which suggests this object might have a very irregular shape, or it could even be tumbling rather than rotating smoothly. Imagine trying to figure out the shape of an object by only watching its shadow. That's essentially what astronomers are dealing with. What makes this even more challenging is that 3I/Atlas is still incredibly far away. Even with our most powerful telescopes, it appears as just a point of light with a faint green glow around it. We can't see its surface features or exact shape. Everything we know comes from analyzing that tiny speck of light and the way it changes over time. The coronal mass ejection that hit 3I/Atlas this week actually gives scientists a unique research opportunity. It's like conducting an experiment on a cosmic scale. By watching how 3I/Atlas responded to that blast of solar material, researchers can learn about its structural integrity, how loosely or tightly bound its material is, and whether it has any unexpected properties that helped it withstand the impact. Multiple observatories around the world are now coordinating their observations, trying to capture every detail of 3I/Atlas's behavior. Ground-based telescopes in Chile, Hawaii, and the Canary Islands are working in concert with space-based observatories. This level of international cooperation is rare, but everyone recognizes that we might never get another chance to study an object quite like this. The data being collected right now will keep scientists busy for years. Every observation, every spectrum, every measurement is a piece of the puzzle, and the picture that's emerging is unlike anything we've seen before, which brings us to perhaps the most controversial aspect of the 3I/Atlas story. Now, I'd be doing you a disservice if I didn't address the elephant in the room. Avi Loeb, the Harvard astrophysicist I mentioned earlier, has suggested something that's got the entire scientific community talking and arguing. He's proposed that 3I/Atlas might not be a natural object at all. Loeb thinks there's a possibility that this could be some form of extraterrestrial technology. Now, before you start planning your alien welcome party, let me be clear, NASA has pushed back pretty hard on this idea. The scientific consensus is still that 3I/Atlas is most likely a comet or asteroid from another star system. But let's look at why Loeb is even suggesting this. First, there's that bizarre trajectory I mentioned earlier, the way it's making these precise, close approaches to multiple planets. Then there's the unusual chemical composition. And now, there's the fact that it's absolutely massive compared to the other interstellar objects we've seen. Loeb argues that the probability of such a large object naturally finding its way into our solar system and following such a precise trajectory is astronomically small. He's basically saying the math doesn't add up for this to be a coincidence. On the flip side, the mainstream scientific community points out that we've only confirmed 3 interstellar objects so far. With such a small sample size, it's entirely possible that 3I/Atlas represents the normal diversity of objects traveling between star systems. Maybe the first 2 visitors, Oumuamua and 2I/Borisov, were the unusual ones, and 3I/Atlas is showing us what typical interstellar objects actually look like. The truth is, we simply don't have enough data yet to make definitive conclusions, but that's what makes this so exciting. We're witnessing something that could fundamentally change our understanding of what's traveling through the galaxy. So what happens now? Well, the timing couldn't be more perfect for getting answers. As I mentioned, 3I/Atlas is going to make its closest approach to Mars next week. This gives us an incredible opportunity to study this object in detail using Mars-based observations and Earth-based telescopes. The big question on everyone's mind is, how did 3I/Atlas survive that coronal mass ejection? Did it lose material like Comet Encke did back in 2007? Did its green glow change? Did the solar blast reveal new information about its composition or structure? Scientists are hoping to get answers as 3I/Atlas zips past Mars. The Mars flyby will give us our best chance to observe this object up close before it continues on its journey out of our solar system, potentially never to be seen again. This is also a crucial test for our theories about what 3I/Atlas actually is. If it's a natural comet, we'd expect to see certain behaviors as it interacts with solar radiation and planetary gravitational fields. If it shows unexpected behaviors, that might lend more credence to the more exotic theories about its origin. The observations from the Mars flyby could settle some debates, but they might also raise entirely new questions. That's the beauty and frustration of cutting-edge astronomy. Every answer seems to come with 3 new mysteries. What we do know is that 3I/Atlas has already provided us with unprecedented data about interstellar objects. The fact that we've now witnessed an interstellar visitor being hit by a coronal mass ejection is scientific gold. This data will help us understand not just 3I/Atlas itself, but how interstellar objects in general interact with stellar environments. The story of 3I/Atlas is still being written, and we're all witnesses to one of the most remarkable cosmic events of our lifetime. Whether it's a massive comet, an unusual asteroid, or something even more extraordinary, this interstellar visitor has already taught us that the galaxy is full of surprises. The collision with the solar coronal mass ejection is just the latest chapter in this ongoing mystery. As 3I/Atlas continues its journey past Mars and eventually out of our solar system, it's carrying with it secrets from another star system. Secrets we're only just beginning to decode. What do you think 3I/Atlas really is? A massive comet from another star? An unusual type of interstellar object we've never seen before? Or could there be something more to this story? Let me know in the comments below, and don't forget to subscribe for more incredible space discoveries. The universe is vast, mysterious, and full of visitors we're only just learning to recognize. Until next time, keep looking up.